Good morning. I'm going to talk about the postgraduate engineering courses in the School of Engineering at Ulster University. My name is Dorian Dixon, and I'm the course director of the Biomedical Engineering MSc and Postgraduate Diploma. And with me today, I've got Dr. Edward Archer, who's going to talk about the other three courses. That's the MSc in Mechanical Engineering, the MSc in Advanced Composites and Polymers, and the MSc in Manufacturing Management. Okay, so why would you want to study at University of Ulster? Well, all of these master's courses give you specialist knowledge. So there's a lot of people out there with a primary degree in engineering, and these masters give you that bit of specialist knowledge to raise you above the rest of the people out there when you're competing for jobs. The biomedical engineering course is designed for people that don't have a biomedical engineering primary degree. So it takes someone who's got an engineering or science degree and gives them specialist skills for the biomedical industry and the medical device industry. Mechanical engineering MSc lifts you up from that bachelor level up to the MSc level in mechanical engineering, and the advanced composites and polymers and manufacturing management MScs or give you specialist knowledge in those areas. And there are excellent conversion courses if you want to do a change in career to get specialist knowledge, give you competitive edge in employment, personal fulfillment. They're taught by experts, so all of the lecturers on the courses are research active in the particular areas that they teach in. So you're getting that access to expert knowledge. Got a supported study environment. The class sizes are typically pretty small, like often 10 to 20 students. So you're getting a real one-to-one experience, and half of the credit points on a master's are made up of a dissertation module and the associated modules with that. So research is a big part of the course. You also get academic and professional qualifications. All of our courses are accredited to the IET or IMechE chartered status, and we have excellent links with industrial bodies and employers. So about 50% of the students are part-time students from industry, so that really brings a lot onto the course. And these are quantifiable benefits. These are across not just the engineering MScs, but across all MScs. So a graduate can expect to earn maybe an extra £8,000 a year on average compared to someone with just a degree. So MSc makes a big change to your typical salary, which turns out to be 266,000 over your career. 20% of postgraduates progress 20% faster than graduates in professional settings, so your career is going to be accelerated. And 90.7% of UK full-time leavers at postgraduate level are working in professional occupations, compared to 72.6% for undergraduates. So you're going to get a better career, have a better lifetime earnings. You're going to progress on average more quickly, and the prospects are excellent. We write to the students after they graduate, and the vast majority of our MSc graduates are either in employment or in further education, going back to a PhD. So into the School of Engineering. We're a very research active school, and the last research assessment exercise, which was in 2014, these exercises rank the research performance of all UK universities, and in the last one, which was 2014, there's one that's just happening at the moment. It shows that engineering at Ulster is in the top 20 within the UK and is a leading materials research institute in Northern Ireland. We've got very, very well equipped labs. We've got injection molding facilities, extrusion facilities, metal forming. On the biomedical side, we've got a cell tissue laboratory. We've got electron microscopes, sophisticated surface analysis equipment, and we've got very, very well equipped laboratories. And as an MSc student doing your dissertation, you're going to get access to that. We were in the top quartile across all research topics in the last ref, and with particular research expertise in areas like medical devices, biomaterials, cell biology, cardiology, connected health, plasmas, nanotechnology, composites, polymers, and metal forming. And then with the typical kind of areas that you would go into to do your final dissertation. The Advanced Composites and Polymers course It came out of a training program that we ran from Bombardier, so it's very industrially focused. A lot of the materials were generated for that course, so you've got a real industrial relevance to that course. And as a school, we have a lot of expertise in spin-out companies, whether that's in the mechanical engineering area or indeed in the medical device area like HeartSign and IntelliSense. So you get excellent job prospects, whether your future career is going to be in academia or industry, and there are opportunities for funded PhD study. And you'll be working with leading research teams. So as part of your dissertation, you're going to be working as part of a larger team. There's small class sizes, as I said, the typical class sizes for the MSCs are maybe 10 or 20 students. So it's a very different learning environment than you would get at undergraduate level. It's a real one-to-one teaching and a real opportunity to get engaged with the lecturers and to ask questions and so on. The courses are flexible. We have a number of optional modules we'll talk about in a minute, so you can tailor the course towards your interests, whether that's more on the electronic side, more on the biomaterials, more on the industrial manufacturing side, or whatever. You can tailor the courses to your interests. And also they're flexible in terms of part-time or full-time study. So full-time study is typically be 10 to 15 hours of contact time per week for the 12 weeks of the taught year. You're going to have to obviously do a lot of work outside that. And then we have part-time options where you would maybe do some classes in the evenings and some classes during the day. So we're flexible. You can do your course full-time over 1 year. So you start in September, do a normal first term with exams after Christmas, then a second semester with exams after Easter, and then you would do your dissertation in the summer. So a normal MSc takes 1 calendar year, but part-time that could take 2-3 years or longer. So we're flexible. So the structure of the courses, you can see that you've got 3 semesters here. So you've got starting in January, the first semester, 12 weeks of teaching and then exams after Christmas in January. And then the second semester running from January through Easter, exams in May, and then in the summer from May to August you do a dissertation. Okay, and for each of the 4 courses, that's the Advanced Composites and Polymers, the Biomedical, and the Manufacturing Management and Mechanical Engineering, you have 2 core compulsory modules in each semester. And in Composites and Polymers, that's Polymer Technology and Composite Engineering in the first semester, then Product Process Optimization and Entrepreneurship in the second semester. For Biomedical Engineering, it's Biomaterials and Tissue Engineering and Advanced Biomaterials for Biomedical Applications in the first semester. And the second semester, it's Bioinstrumentation and Medical Device Development. For Manufacturing Management, it's CAE for Managers and Manufacturing Systems. In the second semester, it's Quality Improvement and Entrepreneurship. And then finally, Mechanical Engineering, it's Advanced Thermal Fluid Sciences and CFD, Manufacturing Systems in semester 1, and Intelligent Manufacturing and Design Optimization of Mechanical Systems in semester 2. And then in the first semester, you do a Research Methods and Management module, and you pick one option. And then in the second semester, you start work on your dissertation in a research project module, or you can do a work-based module if you're a part-time student from industry, and then you've got another option. And then in the summer, you do your dissertation. So that's the full-time structure, and the part-time structure is the same idea, except that instead of doing 4 modules per semester, you only do 2 modules typically per semester. So just to show you the structure here. So this is the Biomedical Engineering structure. So you've got 4 modules in semester 1, 4 modules in semester 2, and then your dissertation during the summer. And the options there include digital signal processing, micro and nanoscale devices, manufacturing systems, and composites, and a module in polymers. So you can tailor your course more towards the electronic side if that's your interest, more towards the material sides, the composites and polymers, or indeed towards the more kind of production manufacturing side. And then the same idea in semester 2, you've got a number of biomedical engineering specific modules, one on bioinstrumentation and another on medical device development. Then you have this research project module, or the work-based equivalent. If you're part-time, you can do your project based upon your work. And then you have 3 options to pick from: entrepreneurship, advanced manufacturing, or quality improvement. Okay, so the same idea, you can tailor the course towards your employment or towards your interests. And then you have the dissertation in the 3rd semester. And the part-time structure, it's exactly the same modules. You just pick fewer of them each time. So instead of doing 4 per semester, you just do 2 per semester. So it would typically take you 3 years. 2 years through the taught element, and then another year to do your part-time dissertation. Okay, I'm going to pass you over now to Edward Archer, who's the course director for the Mechanical Manufacturing Management and Advanced Composites and Polymers courses. Thanks.
Thank you, Dorian. Yeah, so as Dorian said, I'm Edward Archer, and I work alongside Dorian in the School of Engineering. So one of the research topics that I work in is advanced composites and polymers, and we have a number of, as Dorian said, a number of research active staff in this area. We're very lucky in the region to have a number of excellent companies who work in composites, such as Spirit, who took over Bombardier Aerospace recently. So on the advanced composites and polymers, in semester 1, the compulsory module is Composites Engineering, where we're looking at the mechanics of composites materials, looking at the process of manufacturing and designing composites, mostly for the aircraft industry, but also into automotive and even marine now, because we have a strong marine engineering sector in Northern Ireland as well. One of the other compulsory modules then is polymer technology. So similarly, we look at a little bit, it's not much on polymer chemistry, but a little bit of the basics of polymer chemistry, and then into polymer engineering, where we're looking at the process and the design and the mechanical performance of polymers. There are a number of other optional modules then, and the other compulsory module is research methods and management. In semester 2, one of the compulsory modules is process product optimization, and in that we look at a number of different industrially relevant topics, but one of the projects is taking a component and looking at how it's optimized right from the design through to manufacture, and even some of the cost analysis as well. We also bring in some entrepreneurship and innovation engineering. Also then there's the next part of the research project, where you get an individual relevant project to work on, and you're working with a supervisor who's research active in the area. And then there are a number of optional modules before you go on into semester 3 and do your large dissertation. The idea is that the dissertation will be related to something that you're interested in, and hopefully something that's relevant to your future career aspirations. So the next course then is manufacturing management. One of the compulsory modules is manufacturing systems, where we look at a range of the sort of modern manufacturing practices. We also have computer-aided engineering for managers. And again, that research methods and management module, which is compulsory, along with a number of options that you can choose for your 4th module. In semester 2, we've got quality improvement. As you'd imagine, that's very important in any manufacturing sector. We've got the entrepreneurship and innovation engineering. Again, the research project, where you will get your individual project geared towards manufacturing. And then another optional module before semester 3, where you do your large dissertation. And the final course that I look after then is the MSc in Mechanical Engineering. We start off with advanced thermal fluid science and computational fluid dynamics. So very, very important to get a firm, fundamental understanding of all these sort of flows of fluids and thermodynamics as well. We've got manufacturing systems, also then the research methods and management module, and one optional module. In semester 2, we've got intelligent manufacturing. So we're looking at really the sort of the very state of the art in manufacturing and what's coming. You know, we've heard about Industry 4 and, you know, digital manufacturing and all those things that are really revolutionizing the manufacturing sector. We also do design optimization of mechanical systems, so really starting to bring in some analysis of mechanical systems using things like finite elements. We've got, again, the research project, as we have with the other MSCs, and then there are a number of options as well before doing the dissertation then in semester 3. So, you know, Dorian talked about some of the optional module list. There'll be more information about this whenever you apply, but the types of optional modules, if these aren't already one of your compulsory modules, as you can see in semester 1, there's quite a substantial list from polymer technology, composites engineering, micro and nanoscale devices, manufacturing systems, computer-aided engineering for managers, digital signal processing, advanced biomaterials for biomedical applications, advanced thermofluid science and CFD, and finally design optimization of mechanical systems. In semester 2, then, some of the optional modules could be, if these aren't already your core modules, could be entrepreneurship and innovation engineering, advanced manufacturing, quality improvement, design optimization of mechanical systems, or product process optimization. So you can see there is a wide range of different materials that are different subjects that hopefully you'll find interesting. So for applying then, if you're interested in joining us, which I hope you are, because it's a very exciting time for engineering, but also for Ulster University, we've got our flagship research centre down in Belfast, which is NIAS, the Northern Ireland Advanced Composites and Engineering Centre, and it's hosted on land owned by Spirit Aerosystems and has a number of industrial partners as well. We've also just nearly completed our campus in Belfast, so we have a brand new building right in the city centre of Belfast, and at the moment we're moving some of our equipment and some of our research equipment to that building. So if you're interested in joining us, it's a great opportunity. So you can apply online at ulster.ac.uk. There's no official closing date for most courses, and the applications are rolling. So you can start the course in September, or you can start it in January as well, and that will semester 1 and semester 2 will be flipped over, depending on whether you start in September or January. The course places are limited, so if you apply early, it helps to secure your place. So if you're already attending to apply for the course, try to get that application in as soon as you can. You can apply for more than one course, but separate applications are required for each course. And the normal entrance requirements are for the MSc are to have a 2.2 or above in a relevant subject. The postgraduate diploma is lower, so it could be a HND or HNC, and then you can transfer to the MSc upon completion of the postgraduate diploma. So make sure you complete the application. If in doubt, please contact us and we'll be happy to help. The university also has a super international office who can help any of the international students with the application process. But on the final slide, I think we've got some contact information for myself and for Dr. Dixon. There is some information on the web about fees and finance. So the courses start from 6,270 in 2021. There is a flexible payment option, and there's a 10% discount for university alumni, and some other discounts as well for upfront payment, and loans can be available as well of up to £5,500. But if you check those details on ulster.ac.uk for the up-to-date information on the fees and finances is probably the best thing to do. And finally, there's a little thing about COVID. We're currently making preparations to welcome new students for the next academic year, but we will do so safely in line with government guidance. And you can keep up to date with that, what's happening by visiting ulster.ac.uk/coronavirus. So, I mean, we've successfully been able to, carry out our courses mostly online, but now we are getting the MSc students into the labs to do some work and some testing and generate some results. So that's great for everyone. So our contact details, finally, if you do have any questions regarding postgraduate study, please get in touch with myself, Edward Archer, on e.archer@ulster.ac.uk, or Dr. Dorian Dixon is d.dixon@ulster.ac.uk. So thank you very much for taking the time to listen to the presentation, and we hope to welcome you here in Belfast in the coming months.